before you fall asleep tonight, there's something your mind doesn't realize yet. It has never experienced distance the way the universe defines it, not even close. You've imagined big things before, long journeys, huge numbers, endless space. But the universe operates on a scale where imagination quietly stops working. And the moment that happens, something interesting occurs. Your thoughts slow down, your sense of urgency fades, and your mind becomes receptive. This video isn't here to overwhelm you with facts. It's here to do something much gentler, to guide your perception outward, until everyday concerns feel very small by comparison. There's nothing you need to remember, nothing you need to focus on. In fact, the less you try to follow every detail, the better this works as we move through the universe. From familiar space to distances so vast that even light takes billions of years to cross them. Your mind doesn't need to keep up. It can drift, it can rest. The story will continue either way. Most content fights for your attention. This one does the opposite. It invites your attention to soften, because the universe doesn't reveal its scale. To those who rush, it reveals it. To those willing to slow down. So if your breathing deepens, if your thoughts wander, if parts of this blend into the background, that's not a mistake. That's the design. By the end of this journey, you won't just understand the universe differently. You'll feel different inside it. Get comfortable. There's nowhere you need to go. The universe is very patient. And tonight, you can be too. Chapter 1. The problem with big. When people hear about something enormous in space, their reaction is usually immediate. They nod, they imagine size, and then they move on. But there's a quiet issue hiding inside that reaction. The human brain does not truly understand scale, not the kind the universe uses. We grow up learning measurements that work on Earth. Rooms, buildings, cities, distances we can cross in a day. Even when we hear larger numbers, we still anchor them to experiences our bodies recognize. A long drive, a long flight, a long wait. But the universe does not operate within those limits. At a certain point, size stops being something you can imagine and becomes something your intuition simply labels as very large. That label feels satisfying. It feels complete, but it hides how little has actually been understood. This is why facts about space often feel distant. Even when they're astonishing, you can hear that something is millions of light years wide and feel almost nothing, not because it isn't remarkable, but because your mind has no reference for it. Tonight's journey begins there, not with the object itself, but with the limitation that makes it so hard to grasp. If the universe were only slightly larger than our instincts allow, we could adjust. We could stretch our imagination and keep going. But cosmic scale doesn't stretch intuition. It overwhelms it. This is especially true when we talk about galaxies. We tend to think of them as objects. Big ones, yes, but still objects. Something you could point at and say that's it. In reality, galaxies are not simple things. They are vast systems, filled mostly with emptiness, defined more by distance than by matter. And some of them are so large that even calling them a galaxy starts to feel inadequate. The one we're building toward tonight is not impressive because it breaks a record. It's impressive because it exposes the weakness in how we think about size at all. To understand it, We'll need to slow down. We'll need to move step by step, from the familiar to the uncomfortable to the genuinely difficult to picture. There's no rush. Nothing here requires effort. In fact, the less you try to hold on to exact details, the better this will work, because this story isn't about memorizing facts. It's about gently reshaping intuition. So before we go any farther, let this idea settle. The universe isn't just bigger than we expect. It's big in a way the human mind was never designed to process directly. And that's exactly why what we're about to explore feels so unsettling and so fascinating. Chapter 2. Distance isn't what you think. When people try to imagine something far away, they usually picture space being stretched, as if distance were a line that simply keeps getting longer. But that isn't how distance actually works. Once you leave the scale of everyday life, on Earth distance is practical. It's measured in effort. How long it takes to get somewhere, how tired you feel when you arrive, how much changes along the way. That relationship feels intuitive. And because it works so well here, we assume it will keep working everywhere else. It doesn't. As distances grow larger, they stop behaving like journeys and start behaving like environments. You don't cross them, you exist inside them. Think about waiting. Not for something dramatic, just waiting. Waiting in a quiet room, waiting with nothing to do. Time stretches. Not because it's longer, but because there's nothing marking its passage. Distance works the same way. In space, there are no road signs, no changing scenery, no sense of speed. You can move incredibly fast and still feel like nothing is happening. This is where intuition begins to weaken, because the human mind expects feedback. It expects progress to feel like progress. But in large-scale space, progress feels identical to stillness. This is why enormous distances often feel abstract. Not because they're hard to calculate, but because they offer nothing for the mind to hold on to. No rhythm, no landmarks, just persistence. Even within our own cosmic neighborhood, this effect appears quickly. Long before stars blur together, long before galaxies come into view, emptiness arrives first. And emptiness is difficult to interpret. It feels like absence, but it isn't. It's simply space doing what it does best, remaining unchanged over long spans of time. This is why scale in the universe is not revealed through motion, but through patience. You don't see how far something is. You realize it only after nothing has changed for a very long time. That realization can feel uncomfortable, because it removes urgency, it removes narrative, it replaces action with duration, but it also prepares the mind for something important. Because once distance stops feeling like movement, it begins to feel like time. And when distance becomes time, everything about space changes. How we describe it, how we measure it, how we experience it. This shift is subtle. So subtle that many explanations skip past it. But without it, nothing that follows will feel real. So as we continue outward, let this idea stay with you. Distance in the universe is not defined by how far you travel. It's defined by how long. Nothing changes while you do. That quiet persistence, that absence of landmarks, is the true scale of space. And it's only just beginning. Chapter 3. When distance turns into time. There is a moment when distance stops feeling like space. It becomes something else entirely. Time. In everyday life, seeing feels immediate. You look at something and assume you're seeing it as it is, right now, in the present. That assumption works as long as distances remain small. But light does not arrive instantly. It moves, and while it moves incredibly fast, it still takes time to travel. That delay is usually too short to notice, so the mind learns to ignore it. Once distances grow large enough, that habit begins to fail, because light carries history. When sunlight reaches Earth, it has already been traveling. Not long, but long enough to matter. The sun you see is not the sun now. It is the sun, as it was moments ago. Extend that idea outward, and something strange happens. The farther away an object is, the older the light you receive from it becomes. Looking outward is also looking backward. This means space is never observed as it exists all at once. There is no shared present, only arrival. When you look at the night sky, you are not seeing a single moment frozen in place. You are seeing layers of time arriving together. Light from nearby stars, light from distant galaxies, light that began its journey long before Earth was familiar. Your eyes gather all of it into one image, but that image is a collage of eras. This idea feels abstract at first because time usually feels personal. It's something measured in seconds, days, years, but in the universe, time stretches until it becomes geography. Distance and time stop being separate, they merge. This is why astronomers describe space using units that include time itself. Not to complicate things, but because separation can no longer be described. Without it, a distant object is not just far away, it is old. This changes how the universe must be understood. Events do not unfold everywhere at once. They ripple outward, carried by light, carried by influence. Some stars you see tonight no longer exist. They ended their lives long ago. But their final light is still on its way. Until it arrives, they remain present to you. This is not illusion. It is honesty. The universe does not hide its past. It displays it openly, everywhere you look. And as you look far, you see earlier versions of reality. You see structures before they were refined, galaxies before they settled, matter before it organized. This is why the distant universe looks different from the nearby one. Not because laws change, but because time has not yet finished doing its work there. This understanding requires patience. It requires letting go of the idea that now applies everywhere. Once that idea fades, something quiet replaces it. A sense that the universe is not a static place, but a long, ongoing story, still arriving. And this story does not end nearby, because once distance becomes time, scale opens again. In the next chapter, we will return to something familiar, not to reduce the scale, but to anchor it, to see how even our local region of space quietly reflects everything we've just learned. Chapter 4. The solar system is not close together. Up to this point, everything we've talked about has been abstract. Distance, time, light. So now we slow down and return to something familiar. Home. Most people believe they have a rough sense of what the solar system looks like. A bright sun, planets circling nearby, a tidy system that fits comfortably inside diagrams and textbook. That picture feels intuitive, and it is deeply misleading. The solar system is not a collection of nearby objects. It is a vast region of space, with a few small bodies scattered far apart. The space between them is the defining feature. Imagine standing on Earth and looking toward the sun. You already know it's far away, but your intuition quietly shrinks that distance, because nothing in daily life requires you to wait for light. In space, waiting is unavoidable. Even here, inside our own system, distance reveals itself through delay. Signals take time to arrive. Light takes time to cross space, and that time matters. If you could move outward from Earth, not instantly, but slowly, you would notice something unsettling. For a very long time, nothing would change. Earth would grow smaller behind you. The sun would remain distant ahead. Between them, only darkness. This is where diagrams fail. They compress space so the mind can hold it. If drawn to scale, the planets would disappear. The emptiness would dominate the page, so illustrations cheat. They bring everything closer than it truly is. This doesn't make them wrong. It makes them necessary. But it also trains the mind to underestimate reality. Within the solar system, travel is not about motion. It is about endurance. Machines we've sent outward take years to reach their destinations. During that time, life on Earth continues. Seasons pass. Generations change. And the traveler is still en route. This reveals something important. Even nearby space is not quick, not immediate, not intuitive. The solar system feels calm because it is slow. Orbits unfold over years. Changes accumulate gradually. Nothing announces itself loudly. And yet this quiet region already contains distances that defeat instinct before we even reach another star. This matters because if the solar system itself is this spread out, this patient, this resistant to imagination, then everything beyond it will challenge us even more. The solar system is not small, it only feels small because it is familiar. As we prepare to leave it behind, let one idea remain. Space does not become vast suddenly, it reveals its scale early, and it never stops. In the next chapter, we will step beyond our local system and enter a structure so large that the solar system itself will begin to feel like a single point. Chapter 5. Inside a galaxy. Leaving the solar system does not feel like crossing a border. There is no edge you pass through, no moment where space suddenly changes. One day the sun simply becomes another star, and before that realization fully settles, you are already inside something far larger, a galaxy. From Earth, the Milky Way appears as a faint band of light, stretching across the night sky, soft, uneven, easy to overlook. It doesn't look overwhelming, it doesn't look crowded, and because of that it's easy to misunderstand what you're seeing. That pale band is not a surface, it is depth. It is the combined light of countless stars, stacked along a line of sight so long that the mind cannot unfold it. You are not looking at the galaxy, you are looking through it. Inside a galaxy, space does not flatten into a picture. It becomes volume. Stars are scattered in every direction. Above you, below you, ahead, behind. And between them, vast stretches of emptiness. This emptiness is important because galaxies are not dense places. Despite containing billions of stars, the average distance between them is so large that encounters are rare. Space dominates, silence dominates. From the inside, a galaxy does not feel busy, it feels lonely. Stars are not arranged neatly. They do not sit still. They drift. Each one follows a path shaped by gravity, curving slowly around a shared center. But that motion is subtle, so subtle that entire civilizations can rise and disappear without ever noticing it. The Milky Way completes a single rotation over a span of time so long that human history occupies only a small fraction of it. The galaxy turns patiently while life comes and goes on its orbiting worlds. Our sun is part of this movement. It is not fixed. It is carried along with Earth and everything that has ever lived here. It traces a wide, graceful arc around the galactic center. This journey is not fast. It is not dramatic. It unfolds over hundreds of millions of years. By the time the sun completes one full orbit, the Earth it began with no longer exists in the same form. This is what it means to live inside a galaxy, not to stand still within it, but to be embedded in its flow. Galaxies are not objects frozen in time. They are processes. Stars are born within clouds of gas. They age, they change. Some fade quietly, some end violently. And the galaxy absorbs those changes without interruption. Over time, stellar populations shift, new generations appear, old ones disperse. The overall structure evolves, even as the individual stars remain far apart. This slow evolution is easy to miss, because the universe does not announce change loudly. It allows it to accumulate. If you could move freely through the Milky Way, you would not feel surrounded. You would feel distant. Each star a remote island of light, separated by darkness that stretches on for years. At the heart of the galaxy lies a region of greater density. More stars, more motion, more mass, not chaos. Influence. Everything orbits something, and the galaxy bends inward toward this central region because gravity quietly insists that it must. But it's important not to turn the center into a place of meaning. It is not a destination. It is not a goal. It is simply where mass is gathered over immense spans of time. The Milky Way is not unique in this. Galaxies everywhere behave the same way. They form, they rotate, they evolve, they absorb smaller companions, they are reshaped by long encounters. Our galaxy has done this many times. It has merged with others in the past. It will do so again in the future. What you see tonight is only a temporary arrangement. This is another idea that resists intuition. We tend to think of galaxies as permanent, as finished, but they are transitional. Snapshots in an ongoing process, despite its immense size. The Milky Way is not isolated. It exists within a broader environment, a neighborhood of galaxies that drift together through space. From this perspective, the Milky Way stops feeling enormous. It becomes one participant in a larger pattern. This shift matters, because once galaxies are no longer the largest things you know, your sense of scale changes again. The galaxy that once felt infinite now feels local, a single structure within something far more extensive. And yet, even here, calm dominates. Motion remains slow, distances remain vast. The universe does not rush, simply because structures grow larger. As we prepare to step beyond a single galaxy, let one idea remain. The universe builds complexity, without noise, without urgency, without spectacle. Everything that feels immense is the result of time working patiently, without pause. In the next chapter, we will move beyond individual galaxies and begin to see how gravity gathers them into communities. Not tightly, not suddenly, but inevitably. Chapter 6. Galactic Neighborhoods. From inside a galaxy, it's easy to feel alone. Stars are far apart, space is quiet, nothing feels crowded, so it's natural to assume that galaxies themselves must be isolated. They are not. Galaxies tend to gather, not tightly, not dramatically, but persistently. Gravity does not end at the edge of a galaxy. It reaches outward, quiet and patient, pulling nearby galaxies into long-term relationships. These relationships unfold so slowly that they barely register as motion. They look like stillness. If you could step far enough back, you would begin to see it. Small collections of galaxies, moving together through space, not orbiting like planets, not colliding constantly, simply drifting under shared influence. These collections are called galactic groups. Loose neighborhoods held together by gravity over billions of years. Our own galaxy belongs to one. Not a special one, just a nearby one. Inside a galactic group, distances remain immense. Galaxies do not crowd one another. They pass slowly, sometimes interacting, sometimes merely altering each other's paths by the slightest amount. Nothing happens quickly. And yet, over deep time, these subtle interactions matter. They shape motion. They reshape structure. They determine which galaxies grow and which are slowly stripped of material. As we widen our view, groups themselves begin to gather. Clusters form, collections of galaxies, so massive that their combined gravity dominates entire regions of space. A galaxy cluster is not a pile, it is a system. Hundreds, sometimes thousands of galaxies, moving within a shared gravitational landscape, still separated by vast distances, but undeniably connected. Inside these clusters, space is no longer empty. It is filled with hot, diffuse gas, spread between galaxies. Invisible to the human eye, yet massive enough to influence motion and structure. Galaxies move through this environment slowly. They fall inward, they curve, they respond, not to intention, not to design, but to mass. From a distance, clusters appear calm, almost static, but over billions of years, they are places of transformation. Galaxies are stretched, star formation is altered, paths are bent. This is where another intuition quietly fails. We tend to think of gravity as something small and local, something you feel when you stand on solid ground. But gravity does not scale down, it scales up. It behaves the same way everywhere, quietly, relentlessly. When enough mass gathers in one place, gravity begins to guide motion across enormous distances, not just within galaxies, not just between them, but across regions hundreds of millions of light years wide. At this scale, space is no longer a backdrop, it becomes a landscape. With slopes, with flows, with invisible contours that determine where galaxies drift. Galaxies begin to stream toward dense regions. They follow paths carved by mass long before they arrived. These motions are not random, they are organized. But the organization is subtle, too slow to feel, too large to see from within. Clusters themselves are not isolated, they belong to even larger arrangements, connected across space by long, faint structures shaped by gravity's reach. This is the transition point, where individual galaxies stop being the focus, and the universe begins to reveal its architecture. From here on, we are no longer talking about objects, we are talking about patterns. Patterns that emerge only when distance becomes immense and time is allowed to work patiently. Nothing here is rushed, nothing needs to be dramatic. The universe builds its largest structures the same way it builds everything else. Slowly, as we move into the next chapter, we will step far enough back to finally see that structure not as scattered clusters, not as isolated groups, but as a connected network, stretching across the observable universe. A pattern so large that even galaxies become small components within it. Chapter 7. The Cosmic Web. If we continue to pull back, something unexpected begins to appear. Not chaos, not randomness, pattern. At smaller scales, the universe feels scattered. Stars are far apart. Galaxies seem isolated. Clusters appear as separate islands, floating in darkness. But scale changes meaning, and meaning changes perspective. From far enough away, matter does not fill space evenly. It gathers. Long, delicate strands of galaxies stretch across enormous distances. They are not solid structures. They are sparse rivers of matter, threading through darkness. For hundreds of millions of light years, between these strands lie vast regions where almost nothing exists. Immense voids, so empty that light can travel for millions of years without encountering a single galaxy. This arrangement is known as the Cosmic Web, not because it was designed, but because gravity shaped it. Slowly and inevitably. In the earliest universe, matter was nearly uniform, almost evenly spread, but almost was enough. Tiny differences in density, too small to notice at first, were amplified over time. Regions that were slightly denser pulled in more matter. Regions that were slightly emptier lost it. Over billions of years, those differences grew. Not suddenly, not violently, patiently. The result is a universe that looks structured on the largest scales, not smooth, not chaotic, organized without intention. The cosmic web is not rigid, it is dynamic. Galaxies move along its filaments, drifting slowly toward denser nodes. Nothing rushes, motion unfolds, on timescales far beyond human experience. Seen this way, the universe behaves less like an explosion and more like a flow, a slow circulation of matter, guided by gravity's invisible contours. What's striking is how fragile the structure appears, even along filaments. Galaxies are separated by immense distances. The web is thin, delicate, and yet it spans a volume of space so large that no single image can capture it. From within a galaxy, this structure is impossible to perceive. There are no markers, no edges, only local space. It took centuries of observation and decades of detailed mapping to reveal the pattern, not through photographs alone, but through positions, motions, and subtle gravitational effects. Survey by survey, the shape became clearer, not as a picture, but as a realization. This discovery changed how the universe is understood. Large-scale structure is not noise, it is memory. The cosmic web preserves the imprint of the universe's earliest moments. Gravity never forgot, where matter was slightly denser, and it has been acting on that information ever since. There are limits to this structure. On the largest scales, the universe becomes smoother, patterns fade, not because they end, but because distance blurs detail. Yet some structures approach those limits. They stretch so far that they challenge assumptions about how uniform the universe should be when viewed from afar. These immense formations raise quiet questions, not about what exists, but about how large organized structure can become before it dissolves into uniformity. The cosmic web sets the stage for the largest things we can map. It defines where matter can gather, where galaxies can form, and where emptiness will dominate. As we step farther back, we approach a boundary, not a physical edge, but a conceptual one, because beyond a certain scale, structure itself becomes difficult to define. Patterns soften, certainty fades, and the universe begins to resemble its earliest state once more. In the next chapter, we will focus on the extremes, the largest known structures ever identified, and the questions they raise about how much the universe can organize itself before smoothness takes over. Chapter 8. The largest structures we can map. At some point, stepping farther back stops feeling like exploration and begins to feel like restraint. Not because there is nothing more to see, but because the universe itself begins to soften. Up close, structure is obvious. Stars cluster, galaxies form, groups gather into clusters. Patterns announce themselves clearly, but as distance increases, those patterns begin to blur. This is not because they disappear, it is because scale changes what detail means. The cosmic web defines where matter prefers to exist. Filaments form natural pathways. Nodes become gathering points. Voids expand into vast regions of absence. This framework allows structure to grow, but it also sets boundaries. There is a limit to how large organized structure can become before it begins to fade into uniformity. That limit is not sharp, it is gradual. Over the past century, astronomers have tried to understand how close the universe comes to that boundary. They did not begin by searching for extremes, they began by mapping what could be seen. At first, galaxies appeared scattered, then clusters emerged, then filaments. Each new map revealed that structure continued farther than previously believed. As surveys expanded, so did expectations. What once seemed impossibly large became familiar, and familiarity breeds a quiet confidence that perhaps structure continues indefinitely. But the universe resists that assumption. When scientists began mapping hundreds of millions of light years at once, they noticed something subtle. Large structures existed, but they did not grow arbitrarily. They showed preferred scales. Superclusters appeared, massive gatherings of galaxy clusters linked by filaments spanning immense distances. They were not dense, they were not compact, but they were undeniably coherent. Some of these structures stretched across distances so vast that light required hundreds of millions of years to travel from one end to the other. These formations challenged intuition, not because they were unexpected, but because they sat uncomfortably close to theoretical limits. The universe, according to long-standing models, should appear increasingly smooth at very large scales. Matter should average out, patterns should dissolve. And yet, here were structures that seemed to resist that smoothing. This raised careful questions, not alarm, not contradiction, but curiosity. Were these structures truly coherent? Or were they illusions created by perspective, selection effects, and incomplete data? To answer that, astronomers refined their tools. They mapped more galaxies, measured distances more precisely, expanded surveys across larger volumes of space. With better data came better clarity. Some extreme structures remained, others softened. Edges blurred, connections weakened. This process revealed something important. The universe does allow large structures, but it does not favor sharp boundaries. The largest formations are not solid objects, they are statistical patterns, regions where matter is slightly more common over enormous distances. This distinction matters because it preserves a deeper truth. Even the largest structures we can map do not violate cosmic uniformity. They exist within it. The universe does not forbid organization, it tempers it. From far enough away, even superclusters begin to lose definition. They blend into their surroundings, not abruptly, but gradually. This blending is not failure, it is consistency. The universe behaves the same way, at every scale. Small irregularities grow, but growth slows. Eventually, averaging takes over. This balance is delicate. Too much structure, and the universe would fragment. Too little, and nothing would form at all. What we observe exists precisely between those extremes. Some of the largest map structures approach this boundary. They stretch expectations, they test assumptions, they invite careful skepticism, but none of them break the rules. They remind us that nature does not operate in absolutes, only tendencies. As we map farther, we encounter another limit, not of structure, but of observation. The farther away something is, the earlier in time we see it. Eventually, we reach an era before large structures had time to form. At that distance, the universe becomes smoother by necessity, not because structure is forbidden, but because time has not yet acted. This is why the most distant regions we observe appear simpler, hotter, more uniform. The universe has not erased structure there. It has not yet written it. This temporal boundary reinforces a quiet truth. Structure requires patience. Nothing in the universe forms instantly. Not stars, not galaxies, not the vast arrangements that connect them. Everything emerges through accumulation, through persistence, through time applied gently and consistently. The largest structures we map today are not monuments, they are transitions. They show us how far organization can extend before the universe begins to resemble its earlier state again. This realization reframes the question. The question is no longer, what is the largest thing that exists? It becomes, how does structure gradually give way to smoothness? That question has no dramatic answer, only quiet insight. The universe does not end with an edge, it softens into simplicity. As we approach the farthest limits of observation, pattern becomes suggestion, detail becomes tone, and beyond that, the universe grows silent, not empty, just unreachable. In the next chapter, we will step directly toward that boundary, not to cross it, but to understand what it means to exist within a universe where knowledge itself has limits. Chapter 9, Crossing the Distance. By now, scale has stopped feeling dramatic. It has become quiet. That is not a failure of imagination. It is adaptation. At first, vastness shocks the mind, then it overwhelms it, and finally it settles into something calmer, a background presence, something you no longer react to, only exist within. This is the stage where the universe becomes hardest to describe, not because it grows more complex, but because it grows more patient. To cross truly immense distances, nothing dramatic happens. There is no sensation of speed, no feeling of progress, no sign that anything is changing at all. Movement at this scale does not announce itself. It reveals itself, only through duration. Imagine traveling outward from everything familiar, not instantly, not magically, but gradually for a long time. Nothing would seem different. The same stars would remain behind you. The same darkness would stretch ahead, your position would change, but your experience would not. This is the nature of deep space. Distance is not felt as motion, it is felt as persistence. In everyday life, movement is confirmed by change. Landmarks pass, scenery shifts, time feels occupied. In the universe, those cues disappear. You can move at extraordinary speed and still feel completely still. This creates a strange psychological effect. The mind expects feedback. When none arrives, it begins to lose interest. Thoughts slow, attention softens. This is not boredom, it is scale doing its work. Across the largest distances, space does not reward focus. It does not encourage effort, it simply continues. Light itself behaves this way. It travels endlessly, carrying information across the universe, without awareness of arrival. A photon leaving a distant galaxy does not know where it is going. It moves. And moves. And moves. And moves again. Millions of years can pass without interruption, no marker, no checkpoint. When that light finally reaches us, it feels immediate, but its journey was not. This disconnect between experience and reality is one of the universe's quiet lessons. Crossing distance is not about speed, it is about time spent unchanged. Even galaxies crossing intergalactic space do so slowly, that entire civilizations could rise and vanish without noticing any progress at all. From within a galaxy, neighboring galaxies feel fixed, but they are not. They drift, they respond, they follow long, shallow paths set by gravity billions of years ago. These paths are not direct, they curve, they wander, they sometimes reverse. At this scale, motion is not purposeful, it is inherited. Galaxies move the way rivers do, not toward a goal, but along contours they did not create. To cross a supercluster is not to traverse an object. It is to pass through a region. Where structure slowly thins and emptiness quietly takes over. For long stretches, there is almost nothing to see. No galaxies nearby, no filaments, only darkness, with occasional distant points of light. These voids are not empty by accident. They are the result of matter moving elsewhere, pulled gradually toward denser regions, leaving behind expanses where change is rare. Traveling through such a void would feel endless, not because it is infinite, but because nothing marks progress. This is where distance becomes psychological. Without reference points, the mind loses its sense of movement. Time stretches, attention drifts, the present moment expands. This is why the universe at its largest scales does not feel energetic. It feels calm. Even the most violent events, collisions, explosions, collapses, are local interruptions. In a much quieter whole, across the largest distances, nothing competes for attention. Everything settles. This is not emptiness as absence. It is emptiness as stability. The universe spends most of its existence not changing very much at all. When we imagine cosmic journeys, we often imagine discovery, new sights, new structures. But the true journey is learning how much of the universe looks almost the same for a very long time. This sameness is not monotony, it is consistency. It tells us that the laws governing the universe do not fluctuate. They do not adapt to drama, they persist. Crossing distance at this scale teaches a different kind of patience, not the patience of waiting for something to happen, but the patience of accepting that nothing needs to. Eventually, after unimaginable time, structure begins to reappear, a faint glow, a distant cluster, another filament. But even then, nothing rushes. The universe does not greet arrivals, it simply allows them. This understanding changes how we think about exploration. There is no finish line, no moment of arrival that feels definitive. There is only continuation. The universe does not move us forward, it allows us to move within it. And as we approach the farthest distances we can meaningfully discuss, this truth becomes unavoidable. Beyond a certain scale, movement loses meaning, distance loses definition, and observation itself becomes limited. This is not because the universe ends. If anything, it continues far beyond what we can reach. But there comes a point where crossing distance no longer reveals new structure, only more of the same. That point is not a wall, it is a horizon. In the final chapter, we will stop trying to cross distance altogether. We will remain still. And from that stillness, we will look at what can be known and what must remain unseen. Chapter 10. The edge of what we can know. After traveling this far, it's natural to expect an ending, a boundary, a final object, a place where the universe stops expanding and gives us something solid to point to. But the universe does not end that way. There is no wall at the edge of space, no curtain, no moment where reality gives way to something else. What exists instead is a limit to what can be known. Everything we have explored so far, galaxies, clusters, filaments, vast voids, exists within a region called the observable universe. This is not the entire universe, it is only the part whose light has had time to reach us. Light does not travel instantly, it moves, and while it moves, space itself continues to expand. This means the most distant regions we can observe are far farther away now than they were when their light first began its journey. The observable universe is not defined by size, it is defined by time. Beyond its boundary, space almost certainly continues. Structure may continue, time continues, but information does not arrive. And without information, science must remain quiet. This silence is not ignorance, it is restraint. The universe does not hide its secrets behind barriers, it simply places them beyond reach. As we approach this horizon of visibility, the universe begins to look different. Patterns soften, structure fades, not because it disappears, but because distance removes detail. The farther we look, the younger the universe becomes. Galaxies appear less refined, matter appears less organized. Eventually, even galaxies vanish entirely. At the greatest distances we can observe, we no longer see stars or systems. We see a faint, uniform glow, radiation left behind from a time when the universe was dense, hot, and still forming its first structures. Beyond that glow, no image exists, only theory. This is where knowledge reaches its limit, not because we lack curiosity, but because the universe offers no signal from earlier moments. And yet, this boundary does not feel confining, it feels clarifying. Everything we know has been learned from inside this visible region, from one planet, around one ordinary star, inside one typical galaxy. Nothing about our position is special, and that is what makes our understanding remarkable. From here, we have reconstructed events, billions of years in the past, mapped structures, hundreds of millions of light years across, discovered laws that appear to hold everywhere we can see. This is not certainty, it is reach. We do not observe the universe from outside, we are embedded within it, moving with it, changing as it changes, and still, capable of understanding fragments of its story. There may be structures beyond what we can observe. There may be regions forever disconnected from us. There may be patterns larger than anything we have mapped, but none of that diminishes what has already been discovered. Because meaning does not require completeness, understanding does not require total access, and wonder does not require answers. The journey you've taken tonight did not reveal the largest thing that exists. It revealed something quieter, the scale at which questions change. At small distances, we ask where things are. At larger distances, we ask how they move. And at the largest scales of all, we ask what can be known at all. This is where the universe leaves us, not with a conclusion, but with a horizon. So there is nothing left to chase, no farther to go, only a perspective to rest with. You are here, on a small world, inside a vast structure, within a universe that is patient, ancient, and mostly silent, and for a brief moment in its history, you were able to see it. Wherever you fell asleep in this journey, the universe continued without pause, and wherever you wake, it will still be there, unfinished, unending, and quietly unfolding. If you're hearing this now, it's okay to take a moment. There's no need to hurry. You may be waking slowly, or simply drifting closer to awareness. Either way, nothing requires your attention yet. Notice your breathing, not to change it, just to feel it. The quiet rise, the gentle fall. The journey through space has ended, but you're still right where you need to be. Here, if your thoughts feel distant or soft, that's normal. Sleep loosens the edges of attention. They'll return on their own. You don't need to remember everything you heard. Nothing important was missed. The universe doesn't ask for recall, only presence. When you're ready, begin to notice small things around you. The weight of your body, the surface beneath you, the room you're in. There's no rush to move. Let awareness arrive naturally. The same universe you travel through is still there, unchanged. And so are you. Take one slow breath. Then another. Whenever you're ready, you can open your eyes. Or rest a little longer. Both are perfectly fine. This journey will always end quietly. And it will always begin again. The moment you look up, you're awake, you're safe, and everything is exactly where it should be.